So in this section, we've been talking about how to take signals that we usually talk about in the time domain, a signal in terms of values at different time points, and then talk about it in terms of the frequency domain, basically what frequencies are present within a given signal. And what we've been talking about just really at a very conceptual, qualitative level is that Fourier is kind of the tool that lets us translate between these domains. Take a time domain signal, something defined in terms of each time, but then translate it into a combination of sinusoids, in other words, a frequency domain language. Okay? And what's key to this description in the frequency domain are the amplitudes of each of these sinusoids, the amplitude coefficients, and the phasing coefficients, right? And these two pieces of information together constitute our description of a signal in the frequency domain. We then talked about how you can plot these different coefficients, these values, the amplitude as a function of the different frequencies, or the phase as a function of the frequencies, and that these constitute our power spectrum if we square our amplitude, or our phase spectrum if we talk about our phase versus frequency. And again, the idea here is really not to emphasize the math, and I've used math a little bit loosely here, just trying to communicate some of the concepts involved in Fourier analysis. And that's really what I'm trying to emphasize, to give you some insights to what it is and how it works. In further sections, we're going to talk about how to interpret these kinds of amplitude spectra in terms of gaining insights in terms of your signals, and then designing circuits according to those different aspects of what your signal looks like in the frequency domain. I also want to say that we're not going to cover it in this class, but the math within Fourier analysis is something you can explore in other courses. It's actually very, very elegant, and it gives you very useful insights in terms of some of the underlying principles within frequency domain descriptions and time domain, and just basically how you describe signals and gain insights into them. But again, for the purposes of this class and this section, what I'm just trying to convey is some of the basic concepts involved in Fourier.